Good morning, everybody. So, let us start our lecture today. And today is September 16th, right? We are a month. We have completed a month. So, this is the end of the 5th week, right? Okay. So this week we will continue. We will discuss linked list. So, as we started linked list, chapter 5 in the last lecture. So. We will complete. These are the learning outcomes for this chapters. So they explain the concept of linked list implementation in computer memory. Then they explain the concept of node pointers. Okay, the node is the main element in a linked list, and a node contains two things, right? Data and address of the next node. If there is no next node, then the address is null. Okay, then we in last lecture we discussed a little bit constant difference between constant pointer and ordinary pointer. Okay, constant pointer is fixed, it cannot be changed, but ordinary pointer can be changed or updated. So then we discuss arrow operator, and then we stopped about there the linked list function. There are some function in the book, it says linked list toolkits. And today we'll see how to implement those functions in order to complete the implementation of the linked list. And at the end we'll discuss doubly linked list and circular linked list. Okay, so before it starts, there are few announcements. First of all, we will have your test. All right. So next week, this time will be your test 1. Okay, your test 1 will be during your class time. During next class time, okay, your test will be during your class time. So the test will be here in D12. So let us open the syllabus quickly. Okay, we will cover chapter from 1 to chapter 5. Please make sure that you understand the quizzes and you understand the assignments. Okay. And give focus on the topics like that I mainly discussed in the lectures. Okay. And another thing is that you see that quiz 2 is up. Quiz 2 is up, and the assignment 2 assignment 2 is ended, right? Okay, the linked list assignment will be uploaded this week, and it will due in September 24th. Okay, so please take your quiz as soon as possible. It is due on September 21. Okay, what else? So if we go to our content, and this chapter 5 linked list, we are discussing this one, right? So I have opened this one. I should better open from the. Okay.
Does quiz 2 cover everything we've covered up to this point?
No, quiz 2 mainly linked list, on pointer and linked list.
Got it. Thank you.
And test 1 will cover from chapter 1 to chapter 5.
Got it.
Do we? I just came in late. Do we have the date for the test?
Yes. So the test will be next week. This time, I will by this weekend I will send you an announcement, another announcement, and I will send you a study guide. So we have one more lecture before the test. Next, the test will be during your class time. Okay. Okay. So in our last lecture we stopped here. So we stopped here. So we say that the operator is called arrow operator. Arrow operator, how is used arrow operator? Some languages like Java, C++, and then modern programming languages, they use just dot instead of this arrow. Okay, but in C++, you have arrow operator. Okay, so here we stop. So we stop. That is a node. Okay, I believe there is a mistake over here. It should be in parentheses. We'll discuss this. Okay. So here is a node is a class. So node is the main element of a linked list. So we have to declare the node class first. Then we can, once we declare a class, then we can create any number of objects, node objects. For instance, n1 will be new node, and n2 will be another node. So this node is taking default constructor. So it should have parentheses over here after node, empty parentheses. And n2 and n3, these are 3 nodes. So this node, the n1, it takes default value. So default value, since our data type has integer, if our data type has integer value, then it will take 0. If our data type is float type or double type, then it's 0.0. Okay, there is a mistake over here. It should be oh, 1 second. Okay, so here I believe it should be parentheses, and it should be 0.0. So our data type is float. Okay, and then it takes 0 default value 0.0, and it takes given value, and it takes is another node, another constructor. It takes this is value, and this is the address. This is the next node. Okay, that node. Okay, that means this node n3 is linked with n2, linked node. Okay, so that means n1, here n1 is unlinked. For instance, this is n1. and N2 is unlinked. There is no link. But N3 is N3. It is linked with N2. Okay. So this is the way how do we link. And for instance here, now if you say N1, so initially N1 is data is 0. And then if you say N1 equal to N1 arrow set data 10, then it will get the data value instead of 0.0, it will get 10.0. And then if you say N2 dot set link N1, what is this one doing? Then N2 is getting linked with N1. Okay. So you understand this flow? So initially N1 and N2 are unlinked, but N3 was linked to N2. But here in this statement, okay, N2 has set linked with N1, like this way. Okay, N2 is got linked to this way. Okay. So does anyone has any question?
No, sir.
We will see this in a program, live program. Okay, so we will see this in a live program. So there are some common operations for linked list. That means inserting some values in a linked list, inserting a value. The inserted value can be the first value in the linked list, or the last value, or in the any value in the middle. Right? Okay, or removing an element, a node from a linked list. It can be removing the first node, it can be removing the last node, it can be removing any middle node. Okay, and then returning data type. So that means we need to search. We need to find data for the first node or last node or the middle node. Okay, and then we need to get the size. I can find the size, the number of elements or nodes in a linked list. Or we can search a specific, whether a specific element exists or does not exist in a linked list. Then another operation is to check whether a linked list is empty. If the size is 0, the linked list is empty. If it is empty, then size is 0. Okay. And then copy a linked list. Copy the elements of a linked list to another linked list. There can have other operations like appending a linked list with another linked list, or deleting a portion from the linked list. That can have multiple operations. So these are the basic operations we will cover in this course. Okay. So in the book they said linked list toolkit. That means the toolkit means the methods. These are the methods that the implementation of this method for the toolkit. Okay, and in the book is figure 5.10 in page number 254. Page number 254. It's far away, right? 254. Page number 254. So. Okay, this is page number 254, figure 5.10. Actually, these are the methods. Okay. Okay, it is implementation of a node. This is the node class. This is the node class. Actually, here it is here. This is the node class. Okay, we will go through that soon. Okay, we will implement this program. So for us, it is important to know how to work with linked list and pointer variable to be able to define other operations to manipulate the linked list. Okay, so we are not in our program, we are not actually seeing the internal structure of memory, like how linked list is displayed in figure. We are not going that. Okay, so that is the, so we do not see actually how the linked list element and exist in computer memory. We just imagine. So these are the methods we will discuss. Okay, so then these are the insertion operation. If we want to insert an operation at the end for the first one, so this one entry. So if you want to add in the first, so head will be changed. Okay, every linked list has a head. Okay, so operation start from the head and go one by one through the chain. Okay, so if you want to include 13 in this linked list, so 13 will go over here to the top. So then the head pointer will be changed. So however the head pointer is changed, whenever you create a new node, we put entry and then head pointer. So that means the new node, this head, this is linked with the head pointer. Okay, and then these are the operations: inserting, insert operation, insert head, insert in the middle, or insert at the end. So these are the operations. So let me see. So these are the insert. So please go through the slides. Okay, the slides have one by one, everything. Okay. So and then removing an element. Actually, removing an element from the list, linked list, it does not mean that you are completely deleting this element from the memory. It means that you are unlinking it. Okay, so for instance, this is the head element. So this is the, if you want to remove this 13, okay, then head will be the 10, the second node, that will be head. So head pointer will go from, head pointer will go from, so if you want to remove this node, then head pointer will link over here. Then the first element, it is delinked. Okay, if you want to delete the second node, okay, the second, for instance, second node, so then what we'll do, does anyone have any idea how to
Move the
delete
head
the second node?
pointer to point to the next node.
If you want to delete the second node, the first node will be as is. That what we'll do, this one, we want to delete this one, right? We want to unlink this one. So that means the link from here also will go here. That means, so this link will be removed and this link will be relinked to the next node. Then this one will be removed from this linked list, but it will not be removing from the computer memory while the program is running. For instance, if you have a friend in your Facebook, account, in your account, if you have a friend, right? So if you unfriend someone, if you unfriend him, if you unfriend, if John is a friend in your Facebook friend list, okay? So if you unfriend him, John, the John account will not be deleted from the Facebook's media. Okay, so actually what will happen, John is just is delinked, unlinked from your list. Okay. And then if you want to delete the last node, then what we'll do? So this node will point this node. So here this null is going to be here, null will be here. Okay. So these are the operations. So in our we will see this in actual program. Okay. You see that how do we send that? So head pointer equal to remove pointer equal to previous head. We say head dot link. Remove pointer equal to head pointer. Head pointer. This is the remove pointer. This is the head pointer. So this is doing head pointer equal to remove pointer, then arrow link. So then head pointer will be linked to the next one. So that means the second one will be head and this one will be unlinked. So first one, we are saving this on remove pointer, okay, taking a copy of this head pointer. So how do we know that this is pointer? This is the head. So remove pointer equal to head pointer, and then we are making head pointer equal to remove pointer, then arrow operator, then go to the call the link function, and we'll see how the link functions works. Okay. So this is that the statements are very few, single 1 or 2 lines of statements, but you need to understand this. Okay, the slides have like one by one. So please read the slides, okay? I'm gonna better go through a live program so that I can show you how it works. Slide, you can read it, okay? Okay, so any linked list function must have at least one pointer type parameter. Okay, so the pointer a parameter can be either of these. There should be 3 types. Okay, 3 types. Okay, here. Either of these 3 types. Okay, first one is constant pointer. And there is a typo over here. Okay, normal constant pointer. So it is used when the function need to access the list but does not make any change in the list. For instance, if you want to find the length of a linked list, that is how many elements exist in a linked list, right? In that case, you do not need to change any head pointer. Just you need to find the length. Okay, and this is for constant, and value parameter is used when the function need to access the list and any change to do any change. Okay, but it does not need to make a pointer point to a new node. But so this is the difference, but it does not need to, the pointer will not need to point any new node. Okay, for instance, we saw that we created a node element without any link. Okay, so we will see actual function in the program. We will see that how. Okay. third one is reference parameter. It is used when the function need to access the list and it makes a pointer point to a new node. Then it changes the actual parameter. So here, so difference you see that. So it is here. P is a node pointer, and here is a head pointer. It is using at star ampersand, that is address. Okay. So these are the function actually. So you can go through this function, and this actually a linked list operation is recursive process. You may familiar with recursive process. When a function calls itself, that is called a recursive function. When a process is called itself, then it calls itself, but with a different parameter value, with a different argument value. Okay, so we will go through recursive method later, but I believe you are familiar with recursion. Okay. These are the some operations, so we will go through recursion and later. So the book, okay, in our D12 we have you are given these methods, these files. Okay, 1, 2, 3, 5 files. Okay, so if you did anyone try to download this? Last week I told you to try this. Okay. Did anyone had any chance to work on
No,
this?
sir.
Okay. It would be nice, so you could save our time. Okay. There are a few more slides. Let me go to the slides and then we go to program. So here, a circular linked list, a kind of linked list. Last week I discussed. If the linked list, the last element is again linked with the first element. The last element. Okay. How do we know that an element is the last an element or a node is the last node? If it's or is the tail? If its next address is null, that means that is the last element or tail element. And instead of null, so if the null is replaced with the address of the head, okay, then that will be a circular linked list. Okay, we are not discussing circular linked list implementation in this course. This is the concept. And there is another linked list, is called doubly linked list. In doubly linked list, so the linked list by default we are discussing is called singly linked list. Singly linked list means in a singly linked list, each element is connected with the next node. Each element knows is the next node. So a child knows who is his father. Okay. And doubly linked list, each element knows, okay, so each element knows both way. So each node has two things, next and previous, 2 pointers. Next pointer, previous pointer. So previous, it knows that what is his father, the father knows who is his child. So we are not discussing the linked list, doubly linked list implementation, but by the word say linked list, we say singly linked list. Okay. Okay, array versus linked list plus doubly linked list. Array means whenever we send array, it's a random or fixed length array, and it is efficient to retrieve value in an array because in constant time. So we know if you know the index, we can quickly retrieve value. So efficiency is in constant time. Okay. So and then, but it is inefficient. It can lose memory. So we discussed that in regular area, traditional area has problem. And linked list, okay, you know that linked list is an implementation. This is a dynamic array, so there is no scope of memory misuse, memory unutilization. So whatever you need, that much you use, no less, no more. Okay, doubly linked list has advantage over like the linked list because it is like a two-way street. So that means one can traverse both from forward and backward direction. But in a linked list, we only forward traverse in forward direction. Okay, and so C++ has vector. So its vector is implemented using dynamic array, and dynamic array is implemented with pointer. Okay, and list is implemented using a doubly linked list. Okay, and there is called DQ. DQ is implemented with fixed blocks. So we are not discussing here DQ implementation right now in this chapter. Later we will discuss. So if you are familiar with Java and then C#, you will see that list, the array list. Okay, array list is a linked list. And Java, actually C++ program has vector that works more likely as linked list, as list or array list. Okay, then we will post assignment 5 next assignment in this weekend. Okay, now, does anyone has any question before I switch to the program? Okay. Let us go to actual program. So here in our D12, you see that we have this 1, 2, 3, 5 files. Okay, these are complete programs, I believe. And if you put this program in a single program in a package, then it should work. The project it should work. But before I go through this, let me go to my Replit account. Okay. Although we will be discussing with Java, so I have single linked list program implemented with C++, with Java and C#. So I want to give you link of these programs so that if you are interested in, then you can see this. Okay, single linked list implementation example Java. Then it has doubly linked list implementation, and then it has C#, and same thing. Okay. Before I go through our C++ program, I want to give a quick overview of linked list with Java, because its implementation is easy, and then it's easy to understand maybe. So you will realize that it is how easy to understand, and whenever you understand the basic concept, then we will go through with the C++ program. You see that node class. This node class starts at line number 2 and it ends in line number 29. Okay, so see, although there are some spaces, empty spaces, let me delete this so that you can see all in one place. Okay, so you see that node class is started in line number 2 and it ends in line number 22. So this is the node. For every linked list there is a node, and behind the node there is a node class. So node is an element, an object of node class. Okay, so every node class, what does it do? It contains data value. It can contain single data element or multiple data elements. For instance, in this program, the node contains ID and name. So ID is integer type and string type, and it contains next. Another next. Next is the node type. Okay, so this is the recursive type. Node is using itself. The node class is using its own type. So the next node, this next means refers to the next link, okay, made in the linked list, and it holds the reference to the links that was created before it. So next we hold the reference to the link, that means address to the link. Okay, in Java we say reference, in C++ we say called address or reference, whatever we say. Okay, to the link that was created before it. So to the set it is initially set it is null, okay, until it connected to the other link. Okay, let me tell what is this one. So for instance, your node class. Okay, so in your node class you are creating some node. If you have a node class, let me go to program. I will come back here, okay, later. So you see that next it is another node, and it is a node constructor, and it has display method, and it has toString method. Okay, C++ does not have the toString method. Okay, and this is the method in another class, the linked list, within linked list class. Okay, the linked list, this is constructor, and this is empty method is prepend method. Prepend is adding before a node. Append method is adding after a node. Okay, and then remove the first element. Okay, display wall, so find by ID, this is search operations. Okay, so these are the implementation in C++. We put this in a namespace in header file. In Java we put all together. So from line number 25 to line number all the way and to line number 292, this all go with the header file in the header file in C++. But in Java we put all together, and it is the main method. So in the main class, so in the main method we see that how we are creating a node. Okay, so here the node 1 Okay, so we are creating node one equal to new node. You are giving value 1 for ID. Now see how you see that how the node is defined, and this is the name of the node. So let us go to the node class constructor. Node constructor. So node constructor is said that it is taking ID and name. Okay, ID and name. So here these nodes are taking ID. First node, for simplicity, first node we have ID is 1, name is N1. The second node ID is 2, name is N2. The third node ID is 3, name is N3, and so on. So here this node just created, these are not linked with each other. So here what will happen, these nodes will be unlinked node. So for instance, this will be N1, and this will be N2, and this will be N3, and this will be N4, and this will be N5. Okay, and somewhere will be N6. So these links are scattered. There are no link. So in this program, so there is no links. We just created the node. Okay, nodes are not linked. So here, if we display, then node will not know who is next to it. Okay, so this is here. So for instance, in Java, if you say n1.next, okay, then it will see that n1.next equal to null, because at this time no node is linked. No node is linked. And here this is the linking. So before that you see that no, so this is the first one, so that all next is null, and here is the linking. You see that n1.next equal to n2. Okay, that means it says that n2 is linked with n1. That means n2 is a child of n1. Here n2 is a child of n1, and n3 is a child of n2, n4 is a child of n3, n5 is a child of n4. So here the method we used here is node.next, so that copy this here. So the next, it contains what does next contains. So here we have next, right? Next is a node. So next refer to the next link made in the linked list. Okay, hold the reference to the link that was created before it. Okay, so this one n2 n1 must be created before n2. Okay, n1 must be created before n2, and n1.next will be initially n1.next equal to null, and whenever you link it n1.next equal to n2, then it will get the reference or address of n2. So then when you say this kind of statements, so then you will have like this: n1.next equal to n2. That means you will get is shown by an arrow. n2.next equal to n3, like this. n3.next equal to n4, like this. n4.next equal to n5, this. And n5.next equal to n6, and n6.next equal to null. Do you understand this? Does anyone has any question?
No.
Okay, C+ implementation is fresh, and it looks it seems to be easy to explain. And you may see that other methods, these are the methods and implementation for other methods append. So in the book, in C++ book, they call different name. So for method, you can give any name. Okay, so in my program, so I gave the name of like append, so usually prepend. This is the traditional terminology. Okay, you can give any name, other name, but append means add ahead. Okay, so add later and add after an existing node, and prepend means add ahead. Okay, so this in Java all in one file, but in C++ this part will be in a separate header file. The entire part, like this one, it is in Java, it is implemented in a separate class as a linked list class. So then in our main program, what we are doing, we are creating a node, and later we are creating a linked list. And in the linked list, we are calling the append method, prepend method, remove method, this method, and this is then the append methods. These methods, how it works, they are using the node class. These methods are using the node class. So if you took our 1322 courses, you should know this. We discussed this in 1322, but maybe in 1322, whenever we discuss this with Java and C#, you may not understand in detail. So actually, these are first implemented with C++. So C++, you know this implementation with C++, then you are knowing the more in depth or in detail from the scratch. Okay, now has anyone any question? Does anyone any question?
No, sir.
Okay, thank you. So if you don't have any questions, so I want to go to this. So I like you to click over here, click and then download. So if you click download, click on programs and then download. Okay, so I have already downloaded this, or I can download one more time. Oh, I'm sorry. So it's bag3 cpp bag3.h. You can click on the down arrow and then download. Okay, what are the files? We have 5 files over here. Okay, let us see. So this program, previously we saw the bag class that was implemented in traditional way, then first chapter, in chapter 2 or 3, and then later we saw that it was implemented with a pointer. And in this chapter we will see that same bag class is implemented with a linked list. Okay, so how many files are over there? There are 5 files. Okay, by looking these files, okay, so what do you infer? What do you understand from this? Which one is the first file we should start with?
I guess the bag file, bag H file.
Okay. Anyone has any idea? Yeah. Let me get my attendance today. Okay, so actually the node class node1.h header, it should be our starting point. Then node1.cpp, then bag3.h, then bag3.cpp, and then bag3demo is the main. Demo is the main method over here. Main program is here. Main method. Okay, so let us see node1.h. So I can open. Sorry, it's opening with Xcode. Let me open with show in folder. So node.h. Open with maybe atom. This is our node dot. This is our node dot. Node 1. Okay, I'm not going to. This is node.h file. This file needs to save as node.h, and all the from the top it has the information. Please read the description, and in your assignment, from your next assignment, you need to write. This is the called documentation. Okay, that what each function do. So without documentation, you will lose points, substantial amount of point from the next assignment. So this is our node1.h. So do control control A, then copy it, command.control plus C, copy it, and then let us go to a new program. 2 plus, and then C++. Let us give the name, good name. Bag class implementation with list example 1 CPP. So I give a large name so that I can remember. Bag class implementation with a linked list. With linked list, it's fine. Okay, with single linked list, example 1 CPP. So in Replit, it comes with main.cpp. You cannot change this name. Okay, this is the file name. The bag3 demo will go here in main.cpp. Okay, the first of all, then we are putting node1.h, right? So we need to create a file. Click on here, add file icon, then node1.h. Give the name node1.h and paste. So whatever you copied from there, paste everything. So the node1.h, it has node class. Okay, that is node class within the main underscore service underscore 5 namespace. Okay, and then it has public type def, and it has private. They put private data field. And okay, someone trying to present, you don't need to present. Okay, but please watch me. And then private. Okay, so this one. So this is the end of the here. here node class. This is the end of the node class. Okay, and there are other methods for node implementation like size, list method, insert method, value type method, search method, then list search and locate, and there are many size methods and remove methods, remove head, remove any pointer, clear, and then list copy. All of these methods that are mentioned in the linked list toolkit. So these are here. Okay. And the second thing, someone trying to present, you don't need to present. Okay. Do you see my screen? Then will be a node1.cpp file. So now node1.cpp file, and then open with atom and node1.cpp file. This is the implementation of the methods. Okay. And another file, node1.cpp file. Excuse me, who one is trying to present, share his screen? Please stop sharing. Okay, we need one more file, node1.cpp. So then I will put the content of node1.cpp file. You see the node1.cpp file, it includes node1.h file, and it implements the methods. Whatever methods are declared in node1.h file. These are the method, length method. Okay. And so for this program, you don't need to memorize anything, just try to understand the code. Okay. It will take time for you to understand how this implementation, and C++ implementation is difficult. It's not that much easy that you can do in a week. Okay, node1.cpp. What is our next file? Our next file. Okay, now the bag3.h will be our next file. Bag3.h. Now we'll see bag3.h. Bag3.h. I put the content of bag3.h. Bag3.h, it includes node1.h file, and it has this different implementation of this so declaration of the methods, or same methods, okay, that are declared in node1.h, but this will be implemented with linked list. So now our next one will be bag3.cpp. What is bag3.cpp? Showing folder. This one will be bag3.cpp. So let us create another file, bag3.cpp. Put those content. Bag3.cpp, it declares the method that are defined, it defines the method that are declared in bag3.h. Okay, the last one is the bag 3 demo. If you use CodeLight, then you can keep this name bag3.demo or any name you can choose. But since I'm using Replit, so here I will copy this, and this is the method. This is, you see that it has main method. So if we search for main, it has the main method. So since is in Replit, this is our main class. It must be main function must be named. This file must be named as main.cpp. So just I copied those part and I'm putting over here. Here's the main method. This is the main method. Okay, so see the main method is very simple. It has is bag class and a bag object, creating bag object as edges, and then calling get edges, check edges, and the reference are here. But here first is edges objects. Okay, and then program is very simple, and how it does work is get edges. So the get edges is like this. Okay, and check edges method is this. So there's this program, main program is pretty small, but here because in order to make the main program smaller and concise, C++ has the concept of using header file or and more files. So in Java, you see that we saw that all programs are written in one file. You can split in multiple files. Okay, but in C++, so the header files are being put in one file, and then implementation of the header file is put in another file. Okay, and back 3 header files are usually sometimes larger, but for this header file we have some implementation we are getting from header on node1.h. So you see, once you include node1.h, then your task will be more simple over here, because you are calling the entire function over here, all functions, all classes, because there is only one class over here. So all class is one class, no class. Okay, so you see that it has so two things that over here in like whatever is a bag.h. Here usually this book they put this one at the end, but I usually would put it in the beginning. Let's put it in the beginning so that it's easy to see what are the pointers. Give me 1 second, please. Okay, so here the back class. So these are the private header pointer and the size type is many nodes, how many nodes. Okay, and similarly the node.h, it has node class, public type defined, and So I used to put this in the beginning so you can easily see this. So in C++, instead of making every field private, so if you put just private and then put colon, and until you change the access modifier, still all of these are private and all of these are private, public. So node is public. Okay, node class is public. So this is the node method's header. Okay, header is long. Okay, sorry. Header is long. So don't confused about this. Is and I will put here, and then I will put here. So easy. So this one is here. This one is here. This is the node constructor. Okay. And it has set data method. It has set link method, and it return the data value, and it has constant link method. Okay, so these are the implementation. I put like this way so that you understand. Okay, so these are the node.h, node1.h, node1.cpp, bag.h, bag.cpp, and then main.cpp. Now, if we run this one, it should work. Sorry. Value type unknown type. Okay, unknown type name value type in node1.h 133 line number 133 colon 2. Line number 133 in node1.h line number 133. Let me see the error. Oh, so value type is used first before it declared. So we need to go this statement. Okay, then value type is declared over here, and then it is used, then reload. But there will be one more problem. We are still in this program. If we try to run it, there will be one more problem. Do you guess what will be the problem over here still? If you want to run this program, anyone has an idea? I fixed that issue, but still it becomes few more issues. So if I run this program, you will see that now it got 20 errors. I fixed one errors, but it got 20 errors. The problem is that here the node class, these other methods, these are considering as public, private, because I did not change the access modifier to public. I need to change it because this will be used by other files, in other files, by other methods. So it needs to be public. Now I run. Oh, I'm sorry. I'm not running from here. I should run from main method. Okay. Which one? Oh, bag3.h, the same problem in the bag3.h. Bag3.h, I need size type, type diff, size type. This one is declared over here. This is is how they put at the end. Okay, if they put in the end, then it will work. Okay. Okay, from whichever file you run, but it will start from the main method. Okay, so then it is running. So type the ages of your family members, ages in your family, type a negative number when you are done. So as we run this program previously, 10, 12, 14, 16, 18, 20, 30, 40, whatever we check, it will be in a linked list. So we can give as many value as we need. There's no limit. So -1, then just try those ages again. So those will be deleted. 12 will be deleted, like 10 will be deleted, 14 will be deleted. But 145 is not found, so it is asking me to take it again. 14, and then 16, and then 18, maybe 20, maybe 30, maybe 40. So all are done. Okay. So I'm giving you access to this file, this program. Please practice this, okay? Okay, that's it for now. Does anyone has any question?
Yes, sir.
Okay. Yeah, please be prepared for the upcoming test next week, this time, during your class time. Okay. You need to have a webcam. In order to take the test, you should have a webcam, okay? And then you should have good internet connection. By the weekend, I will send you, I will pass a study guide, okay? And meanwhile, start reading the assignments and the book chapters, and you make sure that you recall or understand the quiz questions. Okay, thank you so much.